Hello, welcome to the sixth session in the Introductory Biostatistics Distance Learning course. This is the stated tutorial associated with the fifth lecture, or the fifth session, which was on estimation, where we learned about confidence intervals, the central limit theorem, and those sorts of topics. So this stated tutorial will be focused on how to calculate confidence intervals using the statistical software package that we've been using called Stata. Okay, we will calculate them for means of continuous variables as well as for proportions. Okay, and you'll remember we're working with the SEPO data set, which we already have loaded into our into Stata, and that was a data set that was studying different treatments for HIV-infected patients. Okay, so having the data set preloaded, we can work with it now as is. We're going to look at the CD4 variable first, which is a continuous variable. It can take on a range from 0 to, I don't know, I think 1500 or even more. But it's a measure of a patient's immune status. So the lower the CD4 count, the sicker the patient is. All right, so remember last time we learned the summarize command, which kind of gives us the means and standard deviations and percentiles and so on of a certain variable. So we're just going to do that again. So in the command window down here, I'm going to type in, remember, we can do things in Stata in at least two ways. We can type in the command window here, or we can use the drop-down menus over here. So since we've already learned the summarize command, I'm just going to save myself some time and type in the command. So I'll type in summarize CD4, comma detail. Okay. And you can see now this output gives me the number of observations is 650. The mean CD4 count is 191. The standard deviation is 83.38, and so on. There's the variance. Then the 50th percentile is also the median, 199. And as well as the other percentiles that I would need to calculate, for example, the interquartile range, the 25th percentile, and the 75th percentile. And it gives me the min and the max and so on. Okay, so that is some summary information about the CD4 count. The CD4 counts of the 650 patients in our data set. Okay, but as we learned in lecture, the sample mean, which we have here, is rarely enough information. So we want to calculate the confidence interval for the mean as well. So that gives us some sense of the uncertainty around this parameter. That is to say, if we were to collect another sample of HIV-infected patients, we know that they would have a different mean from 191. So we don't want to just report the mean, but we also want to have some measure of the variability in there as well, and that's where the confidence interval comes into play. Okay? So the easiest way to calculate a confidence interval is to type in the command CI. So let me go down here in the command window once again, and I'll type in CI for confidence interval, and then CD4 is the variable I'd like to get a confidence interval for, and I'll hit enter. And you'll see now, again, the mean is 191, the standard error is there. Remember now, this is the standard error for the mean, which we discussed in the last lecture, which is different from the standard deviation, right? The standard error of the mean is the standard deviation of the mean, okay? And so based on those two values, it gives us the confidence interval down here, which extends from 184.62 to 197.47. Okay, so that's our 95% confidence interval for the CD4 count. Okay, great. Now, what's interesting, and hopefully that you're following along, is that we could have calculated this confidence interval by hand using the output that we got from the summarize command that we did first. And how would we do that? Well, the first thing is we would have to calculate this standard error. The standard error of 3.27 that the CI command gives us is not part of the output for the summarize command. But remember the standard error of the mean, and we saw this in a neat little experiment on the web. The standard error for the mean is just the standard deviation, which we have here, 83.38, divided by the square root of n, where n is the number of subjects that you have in your study. Here, n is 650. So if we took 83.38 and divided by the square root of 650, that would give us the standard error of the mean, which in this case is 3.27. Okay, so now having the standard error, we could add that with the mean, which is 191. And remember the way that we construct confidence intervals. We always have our point estimate, or mean, which is 191.05, minus, and remember we use the t critical value, the t distribution, because we don't know the population standard deviation or standard error. So we use a t distribution with n minus 1 degrees of freedom. N here is 650. So n minus 1 would be 649, and remember that as the sample size gets large, the t approximates the normal. So that critical value is going to look pretty darn similar to the 1.96 that we have for the normal distribution. So anyway, we take our point estimate, 191.05, times the t critical value for 649 degrees of freedom, times the standard error, which we would calculate as the standard deviation, 83.38, divided by the square root of n, which is 650. And then that would be the lower bound, and the upper bound would be constructed in the same way. The estimate, 191, but now plus the t critical value for 649 degrees of freedom times the standard error. And if we carried that calculation out, it would just give us this interval down here, 184 to 197. Okay, so based on what we've learned, we could have calculated this confidence interval by hand, but obviously no need to when Stata can do it very quickly for us. Okay, so now we know that the 95% confidence interval for the mean CD4 count, don't forget that word, because this is a confidence interval for the mean. Okay, so a 95% confidence interval for the mean CD4 count in these HIV-infected patients is 184.6 to 197.47. Okay, great. Similarly, so we now have, by default, a 95% confidence interval. We could have similarly wanted a 99% confidence interval. So how would we have done that? Well, we can go to the command window again, and we type CI for confidence interval, then type in the variable that we're interested in here, it's CD4, so CI CD4, comma, level, parentheses, 99, because now I want a 99% confidence interval, close parentheses, and then I hit enter. And you can see now that instead where it said 95% confidence interval before, it now says 99% confidence interval. And as we discussed in the previous session, as you increase your confidence, your interval gets wider because you want to be more confident that your interval contains the true population mean. And so we see that here. For the 95% confidence interval, it went from 184 to 197. But now, for the 99% confidence interval, it goes from 182 to 199. So clearly a wider confidence interval for a higher level of confidence. Okay? So hopefully that makes intuitive sense. Okay? So how would we have known to type in the CI command if we just didn't know this command? If we were just starting out with Stata and we didn't know this command from previous experience? Well, we would use the drop-down menus as we have before. So how would we do that? We would go to Statistics. And again, we're just starting out, so we're at the first option, Summaries, Tables, and Tests. Summary and Descriptive Statistics. And then here there's this thing for confidence intervals. And I'll click on that. And you'll see I'll get this menu with a variables menu. And so I can just drop this down. And I'll go search for my CD4 variable. There it is. Select it. And you can see there are all these other options. The variable types: normal variable, binomial variable, 0, 1. Remember, binomial variables are the same thing as binary variables, are the same thing as dichotomous variables, namely variables that only have 2 levels, 0 or 1, yes or no, success, failure, disease, no disease, and so on. We'll talk about Poisson variables in the future, but for now we're dealing with a normal continuous variable, so we'll leave it as is. Okay, and here you can see we can change the confidence interval. It could be 95, 99, 97, and so on. There are different options available here. Okay, but I'll just leave it for 95, and then I'll hit OK, and I'll get back the same confidence interval that I got by typing in CI CD4. Okay, 184.6 to 197.4. So that's how I would get the confidence interval using the drop-down menus. Okay, good. All right, so now that's a confidence interval for a continuous variable. CD4 count is a continuous variable. Suppose now I wanted to create a confidence interval, what we talked about at the end of the previous session. I want to create a confidence interval for a proportion. That's for a binary variable, a dichotomous variable. All of these words mean the same thing, a variable that has 2 levels, okay? And so just to refresh ourselves with the concepts that we learned last time, I'm going to generate a new variable. I'm going to generate a new binary variable based on the CD4, okay? So this is what we did in the previous data tutorial. So let me say generate, and I'm going to generate a new variable. I'll call it CD4 category equal dot. Remember, equal dot in Stata's language means equals missing. So I'm just generating a new variable and making it equal to missing for everybody. And I'll hit enter. And it tells me 650 missing values were generated. Okay? Good. So now I want to assign different values to this new variable that I've created. Okay? So namely, remember we said that a CD4 count of 200 has historically been an important threshold for treatment initiation decisions and so on. So I'll create the CD4 category variable that I've created. I want it to have 2 levels, less than 200 and greater than 200. Okay? So the next command that I'll type in is replace CD4 category equals 0 if CD4 is less than or equal to 200. Okay? So what I wrote was replace CD4 category, which is my new variable, and I'm going to set it equal to 0 if CD4, the original variable, is less than or equal to 200. And then I'll hit enter, and it told me 330 real changes were made. That means out of the 650 people, 330 of them have CD4 counts less than or equal to 200. Okay? Now I want to create the second level, which is for those who have CD4 counts greater than 200, and it'll proceed in a very similar way. Namely, I'll type replace CD4 category equals 1 if CD4 is greater than 200. So again, I just wrote replace CD4 category, the new variable I'm creating, equals 1 if CD4, the original variable, is greater than 200. And then I'll hit enter. And it told me 320 real changes were made, so between the assignment of a CD4 category of 0 and the CD4 category assignment of 1, I made 330 and 320 changes, and that adds up to the 650 patients in my sample. Okay, so now I have the binary variable that I want, the dichotomous variable that I wanted. Okay, so remember we learned this command called tabulate. to give us the percentages of binary variables or categorical variables. So I'll just write in tabulate CD4 category. Okay, and you can see 330 people, or 50.77%, have a 0, which means a CD4 count less than or equal to 200, and 320 people, or 49.23%, have a CD4 category of 1, which means a CD4 greater than 200. Okay, so now I want to create a confidence interval for this binary variable. Okay, so how would I do that? Well, it's very similar to what we did before. We just type in CI for confidence interval. Now we type in CD4 category, our new variable, comma, this is where it gets a little different, comma, binomial. This is to tell Stata, hey, you're dealing with a binomial or binary or dichotomous variable, a variable that has 2 levels. Then I hit enter. And you can see what Stata is doing is it's creating a confidence interval for CD4 category of 1. Remember, that was the patients who had CD4 counts greater than 200. Okay? And I know that because the mean is 49.23, which it is for the category 1. And then here's my binomial exact confidence interval, which goes from 45.3% to 53%. Okay? All right, so that is my confidence interval for a proportion. Okay? So note that, as we mentioned, the confidence interval here says binomial exact. You remember in the last session, we talked about how there are different ways of constructing confidence intervals for binary variables. One of them is this exact method based on the binomial distribution. Okay? We might instead be interested in getting the Wilson interval, which is another one that we described. So how would we do that? Well, the command is very similar. We would again type in CI for confidence interval, then type in the variable for which we want a confidence interval, CD4 category, comma, again we have to tell it it's a binomial variable, so I type in binomial, but now I have a space and I type in Wilson. And you can see it gives me the Wilson confidence interval, which goes from 45.4 to 53.06, so there's very little difference between the two. It's just important to know which one you're dealing with and to report it in the papers that you write. So that's the Wilson confidence interval. Okay? So what if I didn't know these commands? I'm a beginner at Stata. How would I just know to do this? Well, I wouldn't. I would go use the drop-down menus, just like we did before. Statistics, summaries, tables, and tests, summary and descriptive statistics. So again, statistics, summaries, tables, and tests, summaries and descriptive statistics, and then confidence intervals. Okay? Now, instead of the CD4 that's already in there from our previous work, I'll scroll all the way down till I get CD4 category. And now, remember, I have to tell it that it's a binomial variable, 0, 1. So I click here, and once I do so, all these different binomial confidence interval options come up. Exact, Wald, Wilson, Agresti-Cool, and Jeffries. Okay? So I can get any sort of binomial confidence interval that I'd like. So I'll leave it at exact, and I'll just hit OK. But again, I could choose different kinds here. And in addition to choosing the different kinds of binomial variables, I can also change my confidence level from 95% to 90% or 99% and so on. But I'll just leave it at 95, and I'll hit OK, and you'll see we got the exact same output for the binomial exact, which is that the confidence interval for the proportion of people who have a CD4 greater than 200 goes from 45.3% to 53.1%. Okay? So you can try this on your own with the different variables, either in this data set or in your own data set that you're interested in. Okay, so that is how to construct confidence intervals for continuous variables and for proportions using stata. I will see you in the next session.